Hi guys, this is your redo for Chapter 4, Lesson 3, Similar Triangles. First time we recorded, apparently there was no sound, so you got a lot of the notes, but you didn't get any of the voice with it. So we're going to redo, and hopefully that will be helpful for you. And so the voice might not match up exactly as it should have from the first time, but we'll do what we can. And so what we're looking at here is we're looking at corresponding triangles, so similar triangles, and so determining if two triangles are actually similar or if they're just two triangles that aren't related. And so when we're looking for similar triangles, what we need to look at are we need to look for the angles. And so corresponding angles are angles that would be at the same spot in the triangle, and they actually need to have the same value. And then corresponding side lengths would be the side lengths that would match up, so the side lengths that are in between the same angles. So when we look at example A, hopefully these two angles pop out at you because they are both 90-degree angles. So we have two right triangles, and so angle A and angle D are corresponding because they have the same value. Angle B and angle E are also corresponding because they're both 45 degrees. And so they are similar, and so then we need to investigate the last two angles, angle C and angle F. And the way we figure out what those angles are is we go 180 degrees, which is the sum of all angles in a circle, or pardon me, in a triangle. And we take away the 90-degree angle, we take away the 45-degree angle, and what we have left is 45 degrees. And if we did that on the smaller triangle, DEF, we would find that angle F is also 45 degrees because there's no other way to make 180 when you have 90 and 45. The other angle has to be 45. And so because both of those angles are 45 degrees, C and F are also corresponding angles. And so we could say that these two triangles are actually similar triangles. And we could say that C and F are similar angles, like corresponding angles, or we could say that C and E are corresponding and B and F are corresponding because they're both 45 degrees. But by the way this triangle is drawn, it looks more like B and E go together and C and F go together. So those two triangles are similar triangles. And so after looking at the side lengths, we could also look at after looking at the angles, we could also look at the side lengths. So either the angles will be similar or the side lengths will be similar. And so side length BA is from the 45 degree to the 90 angle. Its corresponding side length would be ED because it's got the same angles on each end. So those two are corresponding sides. And then the same from A to C would be one of our side lengths, and it corresponds with the side length DF. And so in order for these two triangles to be similar, those lengths would either have to be identical, and so they'd be replicate triangles, or it would be using the same scale factor. So maybe a scale factor of all the side lengths have been doubled or halved or times 3 or times 1/4 or whatever. And then the hypotenuse would also be similar. So looking at examples B and C, these are also looking at the angles for similar triangles. And so you want to match up the angles. And sometimes the triangles aren't turned the correct way. But if we look, angle G and angle J are both 38 degrees. Yeah, my writing skills need to be worked on a little bit. Good thing I teach you about numbers, hey? And so they're both 38 degrees. And so then we investigate the other angles, and I and L are similar. They are both 29 degrees. And so because I and L are the same, and G and J are the same, H and K will be the same because there's no other way to make 180 degrees other than using those same three numbers. Once you have the two values, the third one pretty much has to be the same. And so to find what angle H and angle H equals angle H and angle K, we would take 180 degrees, which is all the angles in a triangle, subtract the two angles that we know, 38 degrees and 29 degrees, and we get a value of 113 degrees. And so this is actually an obtuse triangle because we have an angle that is greater than 90. And then in this triangle for similarity, we could also talk about the side lengths that correspond to each other. And so I think we go through that. Yeah, and so HI, when you do them in different colors, it makes it really helpful to see as well. So HI is red to blue, and KL is also red to blue, so those side lengths go together. And it doesn't matter the order that you write the endpoints, as long as you include the correct endpoints. G to I goes with J to L. Those are both green to blue, and they look like the longest side length of those triangles. And so those are corresponding side lengths, and so they would need to have the same scale factor. And then the shortest side length, which would be H to G, or red to green, and K to J, again red to green, those side lengths would be similar side lengths or corresponding side lengths, so would have to use the same scale factor in order for these triangles to be similar. But we've already proved that the angles are similar, so the side lengths are also going to be following that same scale factor, so they're going to be corresponding. And so all I've done is I've highlighted over the larger triangle just to show you that if we turn it around, it's actually the same shape as the smaller triangle. And so sometimes it's helpful to use some tracing paper and to sketch over your shape and turn it around to sort of see where would sides match up, because sometimes it's not like really apparent. So this next example for C, it's showing two similar triangles again, and showing that sometimes we don't show the angles using, we don't put the values in, but we show the angles are similar by using different symbols. And so either a single curved line showing that angle P and angle M go together, or a double curved line, or the dot. So those are the three most common that you will see when we're looking when we're using symbols for angles. So P and M go together because they have the same symbol. R and O go together because they have the same symbol, and Q and N go together because they have the same symbol. And then likewise, looking for similar side lengths, you would match colors, so P to Q, N to M, O to N, and Q to R, and the longest side length, P to R, and O to M. Oh yeah, I changed the color because it made more sense. Okay, so I highly recommend using different color pencil crayons as you're doing these notes, or pen, if you like to use pen. So then what makes two triangles similar? Well, there's two different things that we can look for, and as long as one of these things is there, we have similar triangles. So we only need one or the other in order for two triangles to be considered similar triangles. And by similar, we mean either an enlargement or reduction of the other. So the two things that they need, you might want to pause this now, is that the first thing is that corresponding angles are equal, so they're identical. And we looked at a few examples of that. And then the second thing that could be there is corresponding side lengths are proportional, meaning they follow the same scale factor. So you're either going to investigate the angles or the side lengths. And for a triangle, it only has to be one or the other. When we look at larger polygons with more side lengths, you will need to have both of those factors there. But for now, for triangles, it's one or the other. It definitely doesn't hurt to double check both. So if we're comparing the angles, again, we have two right triangles, so angle B and angle F would be your corresponding angles, and they are both 90 degrees. And so then when we look at the other known angle, we know that angle A is 37 degrees, and we know that angle E is 37 degrees. Again, we're color coding to help us out. And so the last two angles should also be identical, and the way that we find them is take 180 degrees minus the 90 degree right angle minus 37 degrees. So C and G should also be equal. And if you notice you have a right triangle, you can always just go 90 degrees, take away 37, because that 90 degrees automatically cuts the 180 in half to 90 degrees. And so angle C and G both have a value of 53 degrees. So by using the angles, these triangles are similar triangles. The ABC is an enlargement of EFG, or you could say EFG is a reduction of ABC. And so we're also just going to compare the side lengths just to show you that method. Okay, and so it's always easiest to look in the enlargement direction. And so we're looking from EFG to ABC. And so the two side lengths that would correspond are the EF and the AB. So we need to think what happened to 4 to turn it into 12. And because it's an enlargement, your scale factor is going to be greater than 1. And so we get a scale factor of 3 because you need to multiply by 3. If we went in the other direction, the scale factor would be 1 over 3, 1/3. Now when we look at the hypotenuse, A to C and E to G should be corresponding sides, and they should also follow the same scale factor, and 5 times 3 is also 15. So this side works. And we need to check the last side and make sure that this also has a scale factor of 3. So we're going to check B to C and F to G. And so from F to G, we have a value of 3, and B to C we have a value of 9. And so to go from 3 to 9, we also need a scale factor of 3. So this triangle is similar, and we've proved it using the angles, and we've proved it using the proportional side lengths. But for a triangle, you only need to have one or the other to prove it. So this first example doesn't tell us anything about side lengths, so we need to use the angles to figure out if they are similar triangles. Right now, looking at them, they haven't told me that both of the angles are the same, so we can't be 100% sure. We need to do a bit more investigating. So the first angle that I know for sure is the same is angle P and angle K. They are both 40 degrees, so those should be corresponding angles. And so I'm going to find out what angle R is because we need more information. And so to find angle R, we're going to take 180 degrees, take away the 60 of angle Q, take away the 40 of angle P, and we get 80 degrees. So this now shows us that angle R and angle J are actually corresponding angles because they're both 80 degrees. We're going to do the same for angle L. So take away the 80 degrees of angle J, take away the 40 degrees of angle K, and we get 60 degrees. So that shows us that L and Q are equal. So the corresponding angles are all equal. So yes, triangle JKL is similar to triangle PQR. And so you should always have a statement like this at the end of a question that's asking you if two triangles are similar. Okay, next two triangles tell us nothing about angles, so we can't use angles to solve, but we can use side lengths to solve. And so we need to try and figure out which side lengths are corresponding to see if the side lengths match up. So I'm going to use the largest side length, and we're always looking in the direction of the enlargement. That just makes the scale factor a little bit easier. And so I think, what do I have to do to 6 to turn it into 12? Well, we need to double it. So the scale factor is going to be 2. So all other side lengths should also have a scale factor of 2 in order for these triangles to be similar. So the next side length I'm going to look at is the shortest one on both, and so I should be able to do the same thing, and 4 times 2 is 8. So yes, this side length also has a scale factor of 2. Then we're going to check the last side length, and 4.5 times 2 is also 9. So yes, the scale factor of 2 works for all 3 corresponding side lengths. So yes, these two triangles are similar triangles. And we don't even need to worry about the angles, because if the side lengths are corresponding, the angles will also be corresponding. But this only applies for triangles. Okay, so the triangles are similar because all the side lengths have a scale factor of 2. Or if we wanted to think of the other direction, we could say the scale factor is 1/2. So you need to make a statement like this at the end of your work. Okay, and so it says use what you know about similar triangles to determine the missing side length of the triangles. So what this is saying is we are telling you that these triangles are similar, and so because they are similar, the angles need to correspond and the side lengths need to have the same scale factor. So you're going to try to figure out what the missing lengths are, and we will check these in class tomorrow.